everyone, I'm Dave Thomas, and today I am building a 3D printed V2-like model rocket. Now I downloaded this from Thingiverse, and then I went back the next day to try and find the author information and everything, and I could not re-find this particular kit. And so if anybody out there knows who made a design like this, please let me know, and I'll credit them in the comments. Okay, so these just came off the printer, and the settings for this were a 0.1 millimeter layer thickness. It had 5 outer layers here, and then an infill of 30%. Now you can see in some places we've got a little bit of filament loose here. The author did recommend not using any type of supports in this, and this may be why. It looks pretty good. We'll just take out this loose filament material here. Alright, I'll finish cleaning it up, give it a little finish there a little bit later on. The main thing I want to make sure of is that there is a retaining ring there, so that this basically forms the engine block, and it's still got good thickness. And then over here, this is for the shock cord. Now we're going to have to put a screw eye in here because there's not enough room to actually slip a shock cord through that. Alright, over here on the body tube, we had a stray filament there. A little bit here on the launch lug, we can cut that away. Now you notice the two colors here, I ran out of orange just as it was finishing, and I didn't have another spool of orange handy, so I just made a little bit of contrast here. Now this is supposed to be a 24 millimeter engine mount, and the first time I printed this it didn't fit. So I printed this again with just a little bit larger tube here. Try this with an Estes motor. That is still really tight. Okay, so what I'm going to do, instead of trying to print this again, is first, after I get these things checked, alright, we may have to do a little bit of sanding here. Alright, that's really tight, but it will go together. Alright, up here in the nose cone, we've got the attachment point for the shock cord. A little bit of loose filament here, not a big deal. Alright, and we have a lot of hollow space here. This is going to be a really heavy rocket, and what I'm going to do here, I think, is instead of trying to sand this out and maybe get a 24 millimeter motor up there anyway, is I'm going to put in a motor adapter to fly 18 millimeter motors, and this should still be okay on 18 millimeter C and D motors. Alright, but that'll also give me some motor retention here that I don't have on the original design. You have to friction fit your motors in. Okay, so I'm going to go off camera here and do a little more cleanup of the filaments and then come back. I've cleaned up most of the excess filaments here, and when I printed the nose cone I intentionally did it just a hair smaller, like a millimeter smaller in diameter, because the first time I printed one of these things it was really tight. Now it's just slightly loose here, and this is easily fixable with a little bit of masking tape. Alright, so that's looking good there. I think this area is going to still be pretty tight. Yep. So here I'm going to use some 100 grit sandpaper. And I'm going to first sand the inside of this. And then I also need to sand the outside. Now here I am not planning to paint this at all, so I want to be careful not to scratch the finish of the part that's going to show. Okay, that should be loose enough that we can work with it there. I'm mixing up a small amount of epoxy here, and this is 5-minute epoxy. And we're going to put this into the region of this hole. And then I've got a screw eye here that is going to go into that. So we want this to be perpendicular to the tangent of the body tube here, so it gives us lots of room there to attach the shock cord. I'm going to go ahead and just add some more epoxy around this. Okay, and I might note, if the designer of this particular rocket ever sees this video, I like it, but you might want to consider moving that up just a little bit so we've got more room to work with in there. Alright, now we're going to let this cure, and then we'll put on the shock cord. Here I have some 300-pound test Kevlar line, and the general rule of thumb when using Kevlar is to make it at least 3 times the rocket length. Since this is a fairly heavy rocket for its length, I'm making that 4 times. So the rocket is just under 18 inches, or about 44 centimeters, so my shock cord here is just under 6 feet long. Okay, so one end of this has already been treated with super glue. The other end I'm going to do here. And this is just to keep the threads that make up the line from fraying. You can see how it's doing that now. And this is, Kevlar does that really a lot. Because all the filaments tend to repel each other. It makes it slippery. Okay, so you can just put a little bit of regular super glue on, take a tissue, wipe that off, and that's usually enough, but if you want to speed things up even further, just spray it with a little bit of alcohol, which is all most of the super glue accelerators consist of. Save yourself some money. Alright, and so now what I'm going to do is just cut this off. Still in the region where we've got glue, but we'll cut off the fraying part there. Okay, over here our screw eye is not quite set up in the epoxy yet, so I'm going to go ahead and let this continue to cure. The epoxy on the screw eye has hardened, and it looks to be a really tight fit there. I don't think it's going to come off. If this had been a little bit cleaner in the print, I probably could have threaded it through here and back around. And I'm not really sure which gives us a stronger joint anyway, but this is what I've got. Okay, so now I'm going to thread my shock cord through the eyelet there. And then I am going to tie this on with a double knot or 2 half hitches. Okay, and I'm going to pull that good and tight. And now to lock that in place, I'm going to add just a drop here of super glue to the knot itself. Alright, we'll hit that with a little bit of alcohol to accelerate things. Now before I put this together, I'm going to thread the shock cord down through here and out the end, aft end there. Good, that's nice and hard. Okay, so to put the main body tube on here, first I'm going to check the fit once more, and we want to make sure the launch lugs are in between 2 of the fins. Okay, that's nice and snug, but workable. Okay, now to glue this, you can either use epoxy again or super glue. And actually this type of a joint is what super glue excels at best, because it's going to have 2 like surfaces and just a very thin gap in between it. Super glue does not fill gaps well, but it's really good at surface to surface contact. So here I'm just going to run a bead of super glue right inside the edge. And the body tube can go on in either direction. I just want mine with my blue stripe at the top. Alright, now here once more, I want to make sure that I've got it positioned correctly between the fins. I'm just going to push down. There we go. Okay, and try and get rid of that gap as much as I can. Okay, and I'm going to let that cure for a few minutes. And then next we're going to put in an adapter that will allow us to use the 18mm motors in here. Again, because we don't have any motor retention here, and this hole is just slightly too small for motors to get in there easily. The super glue joining the 2 pieces here has cured, and so now we're going to make a motor mount for this. This is a BT20 body tube cut to 70mm, okay, or 7 centimeters, and this is the standard size for an 18mm by 70mm motor. I got this as a bag full that I bought in a grab bag, but you can just use any BT20 body tube and cut it to length. Okay, I've got an engine block ring here, and we're going to go ahead and put this on first. So just put some glue around the ring. Now this is a little unusual because usually we put glue in the tubes and then insert a ring if we're going to. But this way any excess glue ends up on the outside of the tube instead of the inside. Okay, just remove any excess there, and I'm just going to make that flush. Alright, so that's our forward end of the tube. Okay, on the other end, I'm going to use an Estes 18mm screw-on retainer here. And you can use either thick super glue, or you can use epoxy to put this part together. Alright, regardless of which one you use, go ahead and roughen up the inner surface a little bit to make it easier to glue. I'm going to do the same thing here on the edge of the aft end of my body tube, because we are gluing dissimilar surfaces here, and this is just going to give us a better hold. Alright, here, whoa, got a lot of super glue gel coming out of there, so I'm just going to clean that up, put this on the tube. Alright, and that is way too much there. That's okay on the tube. Apparently that glue just really wanted to be used. Alright, now we're going to put this on. Just going to give it a little twist as we do so. And then check, we've got some inside. So here, you can use a tissue to remove excess glue there. And do so. We don't want to have big blobs of glue interfering with the motor there. Okay. Now the way I want this to come out is that the forward edge of the screw-on retainer there is going to be flush with the aft edge of the rocket. And so my centering ring here, and this is one that Estes makes, it uses a single wide ring instead of two narrow ones. Alright, and so that's going to go right up next to the retainer mount there. So here I'm just going to make a bead of glue going like this. Now before it gets down there, I'm going to wipe off a lot of that excess. There we go. And we're going to put it just like that. And now we're going to let that cure for a bit. I'm making up a little bit of 5-minute epoxy here, and this will be just enough to put the motor mount in. Now I've taken the shock cord and put it back up through the rocket so it's coming out the front end. And so now I'm just going to gather this up on an applicator. Alright, I'm going to put it just inside the rocket, because we're only going to get that green amount of contact there. Alright, and I'm just going to slide this in right until it's flush with the base of the screw mount there. Alright, so once again we're going to wait for that to cure. The epoxy on the motor mount has cured, and so the rest of this should go together fairly readily. So we'll take the other end of the shock cord here, and we're going to thread that around this little mount inside. Okay, and again we'll tie this off with a double knot or 2 half hitches inside. That down good and tight, and then just like we did on the other end, we'll just put a little drop of super glue right there to hold that knot in place. Okay, now we've got lots of hollow space up in here, and we'll definitely want to do a swing test on this because I have no idea where its center of pressure or center of gravity are at this point. Now for the parachute, I'm going to come down here about 15 centimeters or so. We'll say a nose cone length. Alright, I'm just going to tie a loop in here. It does not need to be large. Just big enough to tie the parachute to. Okay, now I don't have an open rocket file for this, and it would be kind of difficult since it's all molded into just 3 pieces here. What I will do is find an approximately same size V2 rocket that's been done in either Open Rocket or RockSim, put in the weight of this rocket, and then see what size parachute is going to be needed. It may not tell us enough about its stability and aerodynamics, but we can at least find out how the descent rate is on various size parachutes. So I'm going to go do that quickly and then come back. I weighed the rocket, and just as we've done so far, it weighs 240 grams. That's pretty heavy. And doing a quick and dirty simulation on open rocket determined that we're going to want a 24-inch parachute, which I've got one of the Estes ones, and probably we're going to have to add some nose weight to it. And because of all that, we're going to be limited to 18 millimeter composite D motors in this. So both Quest and Aerotech, which are the same company but have different brands, have motors that fit into that. And our apogee is only going to be in the range of about 80 meters to about 180 meters. So not a lot of flight range there. So one of the things I'm going to do is see what else I can do about modifying this a little bit so we can print one that actually does have a 24 millimeter engine mount that's workable, and also use a little less infill so that the overall weight of the rocket is lighter. Okay, I am going to go ahead and finish building this since I put the time into it. This print was 36 hours long to do the whole thing, so definitely worth finishing things up. Alright, so we'll just open up our parachute here, and I've got a snap swivel, and this is about the largest one you can get. Beyond this, you have to start using barrel swivels and quick links. Okay, so I'm going to open this up. Alright, so this is an octagonal parachute. And something else I'm going to add here is a little piece of shrink wrap tubing. And we'll use this to hold the parachute lines together. Okay, so first I'm just going to find all of the loops here of the parachute. Alright, so get all these shroud line loops. Alright, I'm just going to hold these on one finger, and then I'm going to grab the center of the parachute sheet, or close to it, and now I can modify where I'm holding over here a little bit, let that slide a little, as well as letting the shroud lines slide a little, so that we get most of the corners down to approximately the same level there. Okay, and that looks pretty good there. So now I'm going to grab these. I'm always going to have at least 2 fingers pinching these so that we don't lose the relative lengths. Okay, this is shrink wrap tubing that you can find at just about any place that sells electrical supplies. I got mine at Harbor Freight. I know that Home Depot has it as well, and many private independent hardware stores will also have it. Alright, and I'm going to reacquire my loops. Okay, and then these are going to pass through the swivel end here, and this is why I need such a big swivel. This is about the best I can do. There we go, with such thick shroud lines there. If these were even just a hair thicker, we'd have to go to a larger barrel swivel and then use a quick link to attach it. Okay, so then we're going to pass the whole swivel through the loops of the shroud lines, and now we're just going to pull that tight. Okay, and it's going to try and bunch up there, and that's fine as long as it's not bunching up on the actual swivel. Okay, and now we're going to check our shroud line length once more. That still looks pretty good. And so now I can move this up to right at the snap swivel, and I'm going to apply some heat just using a butane lighter here on low setting. All right. And you want to get this close enough to shrink the wrap, but you don't want to melt the shroud lines nor burn your fingers. can see that shrinking down now and conforming to the shroud lines. A small heat gun will also work, though most of them I've seen are too big. You'd end up melting the shroud lines. Alright, now if you don't have the shrink wrap tubing, you can just apply a little bit of white glue to the knot to keep it in place. But this gives it kind of a more professional look. And also, if you do need to change things out, you can just slit this with your hobby knife and untie it very easily. Okay, so now let's open this up. And I've already applied some masking tape to this to make it a little bit tighter fit. And I've stuffed the shock cord down in there. Okay, so we just want this loop here. And that's where our snap swivel will come in. So we just unsnap the snap, put it through the loop and snap it back on. And by doing it this way, it puts less strain on that anchor in there. So with something like this, this could get caught and then levered against that, which could potentially break it, and we don't want that to happen. All right, so by having the parachute attachment point out a little further, it prevents that from happening. Just move that little bit out of the way. Okay, now to fold this, this is going to be a little bit different from what I typically do with a hexagonal parachute, but we'll do it in more or less the same way. Okay, so I'm going to line up these corners all the way around, except at the very top. So this is just a single corner here and a single corner here. Every other corner has a match. All right, so I'm going to take the outside corners, fold them onto the next inner ones, and then I'm going to do that again. So now that corner overlaps that way, and this corner overlaps that way. So now all of our corners are down here. All right, move those shroud lines down. And I'm going to take all of my shroud lines here and find about the halfway point and make that a loop up inside. Alright, so that we just have about an inch or inch and a half here, in my case the length of the heat shrink tubing hanging out. Okay, and now I'm just going to fold this side over the shroud lines and then this side over that. Alright, I'm going to take this spike part and fold it in half and down like this, and then I'm going to fold or roll the rest of this down. Okay, now if you're prepping this for launch, you're going to want some recovery wadding or dog barf, or even a recovery blanket. I actually forgot to put that on here. So this is just a piece of Nomex. It's a flame retardant material. And I make these myself, just getting bulk Nomex and sticking it on a laser cutter. But you can also buy these from lots of different places. And so for this, I'm going to unhook my parachute temporarily, and I'm just going to put the loop of the shock cord through there, and now we're going to put this right back on. And so you can use this instead of recovery wadding, and we simply wrap the parachute now in the little blanket. Okay, and then we're going to put our shock cord back down inside here. Now the Kevlar shock cord is very flame resistant, and so it doesn't need to be protected by wadding. Alright, and we'll put our parachute down on top of that, and it kind of forms a piston there. Okay, and then our nose cone there. We're going to give this a shake test. Alright, the nose cone is trying to come out. Alright, so I'm going to put just a little more tape on there. It looks like we can use an entire circumference of tape. So I'm just going to take this old one out. I put a full ring of tape on the nose cone here all around the shoulder, and that was sufficient. And then I put this Quest D16-6 motor up in there and gave it a swing test, and surprisingly it was stable. And I believe the reason for that is that proportionally this is longer than an actual scale model of a V2, which is probably why the designer called it the V2-like rocket. It's got a longer overall body section right here. Now, to fly, I would not fly using this one. It needs a D16-4, and that's true of most of the D engines that will fly in here. You want an ejection charge or a delay charge of around 4 seconds, maybe around 5 for the more powerful ones. Okay, but this should be ready to go for launch. I would, whoever the launch control and safety officers are, let them know this should be a heads-up launch with this. All right, but I think it's going to fly. All right, it was an interesting build trying to get a 3D printed model together like this, and hopefully this will fly well. So please stay tuned for more of my videos.